Okay, so good afternoon. So this is going to be a kind of a different talk. Um, so I'm going to be talking a little bit about my experience teaching optimization. So I've used JuMP, I used cvxpy, and I've used pyomo. And it's first and foremost a big apology to everyone here that knows a lot more about these packages than I do, right? But from the teaching perspective, I also think it's reasonable to see how someone who's not part of the core developers can try to approach teaching these, and where are the pitfalls that I'm not really aware of, but you probably will be. So just to give you a bit of context, I actually did my PhD and everything leading to it in pure math. So I'm not exactly someone from computer science, although I love that a lot and I studied that, but that was not my focus. And I moved to optimization and stochastic optimization in 2016. And that's the same year where I did my first course. I taught my first course in convex optimization. And well, because it was convex optimization and I was more familiar with Python, and I already taught some courses in Python, I chose cvxpy, which seems very reasonable for the course. And then in 2017, I started a project for a Brazilian energy operator using sddp.jl. And that was the early days. I think we had Julia 0.6, not even 0.7. And some years later, we developed packages building on top of sddp.jl and actually building some interfaces with jumps and solvers. So that was done in 2019. I got bitten by the Julia 1.0 transition and the PKG environment. I'm not sure I completely mastered these things yet, but that's something that I have in some way to teach my students how to do, right? Because if you're working in Julia, you have to know a little bit the language and the package ecosystem. It's been getting better. I have watched new things, but my build-up experience has come from these times. So I probably have to refresh my own self. And I did some more packages afterwards. So one for investment problem, sampling risk budgeting, someone related to research, which is the dual STDP, which is not that much related to the STDP.jl beforehand, except that it has kind of the same problem, but not at all the same algorithm. And a new one with Joaquin, which is linear decision rules.jl. And after that, or kind of at the same time, in between that, I taught 2 courses using Pyomo for an MBA in data science. And the main reason for Python was that Python was probably more common again. And very recently, I gave a short JuMP course in the summer program. So that was like a 2-week intensive, like 3 times a week course, very much inspired from Oscar's tutorials that he had in 2023. So that's a bit of what I have been doing. So that's not too many courses. I mean, the convex optimization course had several editions, and I have done one other like advanced convex optimization as well using cvxpy in between these. But this is just to give a bit of a sketch of what I have been doing. So just general thoughts about teaching optimization, probably irrespective of whatever framework you're using, is that you probably have to have a math introduction to that. I mean, I guess everybody is aware of that, but putting down the formulation and having some training for the students for modeling and how this works is really important, because of course they can read the tutorials that have you explain what's the knapsack problem or transport problems and stuff. But then they get kind of confused if they don't have like a basic like optimization OR course beforehand. And from my experience, it takes a click for the students to go between the models to the applications, and especially to do something that I have seen here, and I appreciate that very much, is like building up several components of a model into a bigger optimization problem and linking these things together. And that's something that students sometimes find very difficult. And one of the linking things between that is that sometimes you have to add auxiliary variables in order for your models to actually work. You need that, and sometimes the idea of putting these auxiliary variables, students will, I mean, once they have seen one, they can replicate that, but for them to have the idea, oh, I could have one and invent one, it's fairly hard. And the good thing about the frameworks is pyomo, cvxpy, and JuMP, they're very close to mathematical notation. It's very good. But on the other hand, a lot of the students, and sometimes even myself, I have some trouble explaining the difference between what are the program variables that live inside your programming language and are in like silicon, and the problem variables which live in the mathematical world. And you kind of have some way from getting from the one to the other, but that sometimes generates a lot of confusion. And I mean, it's nice, and it's kind of part of the click. At one point, students will understand where each thing is living, where, what are the math part, what are the computer part, and how they go together, but that takes some time. And well, big thanks for fast, reliable, and free software that has been doing like a big difference. It's amazing. I mean, I know there are commercial solvers that do a great job, but for teaching and having like free software that students can just download and use, moreover in Brazil, that's amazing. So a big thanks for everybody that does this, and that has been a big thing for us. So let me just go quickly about like specifics of each language. So what I like about cvxpy and probably convex.jl, but I have not used convex.jl very much. I have probably written like 2 or 3 problems, but that's not a representative thing. cvxpy, because of my courses, I have a little bit of more experience. So the first thing, which is kind of annoying to talk to a Julia audience, but I think that object orientation is more familiar, sometimes seems more natural to students. You create a variable, it's probably more something that students relate to, then you have the macro that creates the variable for you. Of course, if you are from CS, you understand what this macro is doing under the hood, and you see the creation of the like programming variable X. But the notation sometimes seems more like natural to have object-oriented for programming. And then, well, convexity checks is good. I assume convex.jl has that. I don't know at all how JuMP has convexity checks. It could be an amazing thing, because when you're teaching, and you're teaching convex optimization like I did for like almost 8 years now, it's good to have something that your students can use and that barks at them, no, this is not convex anymore. And then they go back and they realize themselves without having to ask for help from the professor. They can just use the programming language to do that for them. And because it enforces a computational graph, I also find cvxpy very nice. In JuMP, I don't know very well how you can build this computational graph where you put this abstract operators like norm, blah, blah, blah. I think that's something that's possible, but I think that cvxpy kind of enforces this more directly than JuMP. So now JuMP. So first thing first is that if you have cvxpy, you're probably restricted to convex optimization problem and sometimes mixed integers in some very simple way. So JuMP doesn't have that. You can put everything. And because you can put everything, you can put all models you want. And students can see like immediately that they can do a lot more applications, because they don't have to think, oh, is my model going to be convex? No, they just write whatever they want. And it's a fun fact, because at this course that I teach, all students have to have some like small final project that they have one problem that they motivate and they solve, and they see how this optimization worked for them. And most projects that I have proposed upfront, they were non-convex. Some of the students I could convince that a convex model would do a good job for them, and they changed all the non-convex stuff to a simpler convex model, because it was kind of the point of the course, right? But for several of those, I looked at what they were trying to do and said, no, this is no way I'm going to give you a convex surrogate for that. It's going to be awful. And I told them, okay, you know Julia, let's do JuMP, and you can try in Julia. But so that was one of the funny things about having JuMP like middle through my courses. And another thing that's kind of like small issues, but I like that variables are attached to models. In cvxpy, sometimes you can put variables that are not exactly related to a model, and I have found students, and sometimes myself, having some kind of programming errors just because you were accessing some variable in a different model than it was supposed to be. Just because you're like big one file having all your code, which is not what you're supposed to do, right? But when students are starting to learn, they cannot follow all good practices in the first place. And documentation in JuMP is excellent, so that's been a big help for teaching. I love it. And I like resolves because that's something that students will very often do. They take a problem and try to resolve. And resolves are good, and I put that before coming here today. So, well, I have seen parameter JuMP and I have seen other stuff. So I like that you're able to solve. I'm not sure if warm starts are completely baked into parameter JuMP. You can tell me more afterwards. And finally, for pyomo, I have not much experience because these were like only 2 courses in Zoom classes, so it's not exactly the same experience as in like in-person classes. But I mean, the reason it was pyomo is because it was Python and I needed non-convex models, right? So and I kind of decided that I really wanted a framework, and that's kind of what made my choice easier. And I also like that they have this abstract model where you have this kind of generator expressions. So someone here, unfortunately I don't remember anymore, this morning told about this abstract index variables where you can have a function that builds after the index. So that's something that I was not aware of, so that's very nice. I'll probably look into, because as I believe this is closer to how I think and most people think and teach about optimization. You have somewhere your abstract model where you have the indices and everything, and then somewhere else this becomes concrete and implemented when you read the data, so the size of your model and everything. And well, one of the things that I think that Julia has a little bit of an introduction to that is the knapsack design pattern tutorial from, I believe, the recent Oscar presentation, but maybe that was even before. But I got to know that because of Oscar's tutorials. So, and the only drawback of that, again, coming back from what I teach, is that students find these generator expressions sometimes magical because they don't see how it's implemented under the hood. So that's always something that has bothered me, because the more powerful and abstract you get, the harder it is for the students to understand what's going on. And it's nice to get from this very concrete to a more abstract construction, but sometimes this transition from one way of thinking to the next one will impose some kind of difficulty for them. And so a final slide was about things that I would like to have in JuMP, and apologies if they already exist, and some of them already exist. I've seen some today. So one is having abstract linear algebra for structured matrices. So this is something that I always, in some advanced courses, I tell students, oh, it's important that you have structured matrices and everything, because then you can solve faster, because you don't need to invert the Hessian if you know the Hessian is a diagonal plus something you have specialized methods for that. I'm not sure that exists. It would be nice to know, and if it doesn't, it would be nice to have the block hashing that we have seen maybe is a good way of doing that, but I believe that could be even further things. So convexity checking, as I mentioned, and convex.jl integration. I know there has been done some work in that, so that's cool to know. And kind of first impressions, because when you show Julia to the students, sometimes they install a lot of things, and the first run takes a lot of time. And if they shut down and come back again, every class they have to start Julia and have things fast again. And I mean, in my computer, which is a Windows, I have a 20 gigabyte .julia, and I don't have that many projects. It's just that I have downloaded a lot of packages, and I have a lot of stuff pre-compiled. And well, on my computer, 20 gigabytes is not that much. But for some students, they don't have that much space left on their hard drives all the time. So that sometimes makes me wonder if we can do anything. But I know this is not a JuMP issue. This is a more outstanding Julia thing. So with that, thank you, and I would love your comments and suggestions on that. Question?
Yeah, thank you for sharing your experiences. I was just wondering what the student profile is, because if I understood correctly, you are also teaching MBA students? Or?
Right. So yeah, sorry. Some of the courses were for like 3rd and 4th year undergraduate students. The MBA students are like post. Mathematics, mostly mathematics, applied mathematics, some engineering. Not many students from computer science. Yeah, well, I put MBA because I'm not sure what the closest would be, but it's a postgraduate, not exactly master's, but close to that in data science and applications.
So then a follow-up question, if I may. So what would you think of your experience also would apply to like business students who have just started learning programming at all?
Right, yeah. So I can give some shares on that. So usually, as I said, you have this build-up from teaching like optimization, mathematical modeling, and programming before the students can be efficient in using optimization. And kind of a reflection on David's talk is that if you have a package that corresponds to solving the problem that you're interested into, and you only have to give the data and it will give you the solution, it's way easier for the students to use than to come up with the model and everything. So this is kind of a barrier for the students, and I had a little bit of that experience from the students on this MBA, because not all of them had previous exposure to mathematical modeling and stuff like that. So it's kind of a bet that you have the students for them to buy into, okay, I'm going to spend some time learning just the mathematical setup in order to be able to do more general methods, as David was explaining. If you have a package that does your ARIMA, it's good. If you want to do something different, you cannot, unless you use optimization, like roughly. So that's something that I try to convince the students, but there's a bit of a resistance from some of them.
Yeah, so I was wondering, like, when you're teaching courses for people that are graduate students, do you feel they have different opinions towards JuMP and cvxpy? So when you're teaching like more complicated methods such as like cutting planes, I don't know if you got to that, but do you feel like there's a different pros and cons when you're getting to like higher level stuff, and you need to teach, and you need to choose which optimization framework you're using?
So I didn't get exactly that feedback. I mean, mostly because my more advanced courses, I already knew Julia, and I was more familiar with Julia than CVX in doing this kind of operation. But I don't think for the courses that I taught, students would not have been able to use cvxpy. It's maybe not going to be as fast in model rebuilding and everything, and I don't have a data point for that. It's just, I know that JuMP people have spent a lot of time optimizing these things, but I presume that most students that kept using Python in my graduate courses is that because they felt more familiar with Python and didn't want to learn Julia. That's I think, the basic split that I get.
Okay.
Any other questions? So let's thank Bernardo.